This weapon costs less than $20 and is neither explosive nor bullet-firing. Yet on Ukraine's front lines, it outsmarts Russian drones and transforms high-tech warfare in a way that few other innovations can match. In the modern era of conflict, as drones increasingly dominate battlefields, from kamikaze FPVs designed for one-way attacks to sophisticated long-range loitering munitions capable of precise strikes, stopping these aerial threats has become just as vital as deploying similar technologies for offensive and defensive purposes. Ukraine's military arsenal is impressively diverse, ranging from billion-dollar Patriot missile defense systems, which provide strategic protection against ballistic missiles and aircraft, to improvised quadcopter-mounted shotguns and other DIY countermeasures crafted by resourceful engineers on the ground. Among these varied tools, the Aerotrol stands out by offering a uniquely effective and elegant approach. Rather than destroying enemy drones from a distance, it captures them midair, using lightweight nets or other mechanical interception means, delivering the enemy drones intact to Ukrainian forces. This capability not only prevents damage to critical infrastructure, but also allows Ukraine to analyze captured drones thoroughly, gaining valuable intelligence on Russian drone technology, tactics, and payloads, which can then inform future counter-drone strategies and defense planning. The low-cost nature of the Aerotrol, which can be produced for less than $20, makes it especially valuable for Ukraine's budget-constrained military, enabling mass production and widespread deployment across multiple units with minimal logistical burden. Its simplicity also allows for rapid training and deployment by frontline units, ensuring that soldiers can adapt quickly to evolving drone threats without reliance on complex electronics or costly maintenance. While Ukraine combats Russian drones on two main fronts, defending cities and civilian areas from missile and kamikaze drone strikes using integrated missile systems, air-to-air missiles, sophisticated electronic warfare suites, and vehicle-mounted guns, all supported by radar installations and thermal detection technologies, it also faces relentless drone activity on active battlefronts where maneuvering forces engage directly. Both sides rely heavily on reconnaissance drones for real-time surveillance and targeting information. Russian forces frequently deploy Orlan-10, 4-post, and the more advanced 4-post R drones, which provide persistent aerial coverage and enable coordinated artillery strikes. Conversely, Ukrainian forces utilize domestic drones such as the Zastava, Tachyon, and Zala models, which conduct constant rear-area surveillance to identify and track Russian tanks, artillery positions, and UAV operators, ensuring that frontline units receive timely intelligence to counter enemy moves and protect their own assets. This dynamic interplay of drone technologies and countermeasures underscores the rapidly evolving nature of modern warfare, where inexpensive, innovative solutions like the Aerotrol can significantly shift the balance in favor of defenders, highlighting the strategic importance of adaptability and creativity in the face of technological challenges. As drone technology continues to evolve rapidly, Ukraine's ability to integrate low-cost innovations alongside high-tech systems exemplifies a broader trend in modern conflict: the fusion of traditional ingenuity with cutting-edge technology to create multi-layered defense networks that are both resilient and scalable. It is absolutely vital for Ukraine to rapidly and effectively shoot down reconnaissance drones in order to deny the enemy critical battlefield intelligence that significantly enhances their operational capabilities and strategic decision-making. By neutralizing these drones swiftly, Ukrainian forces can better strengthen their defensive positions, coordinate artillery strikes with greater precision, and efficiently supply frontline units without the constant threat of enemy drone surveillance and strikes, disrupting their efforts or compromising sensitive movements. In the early stages of this conflict, Ukrainian infantry primarily relied on relatively simple yet innovative countermeasures such as pump-action shotguns and short-range electronic warfare (EW) kits designed to disrupt the communication and control signals of enemy drones. These disruption tactics caused drones to lose their targeting accuracy or even crash, thus reducing the effectiveness of enemy reconnaissance and targeting. Over time, these anti-drone tools have become widespread and are now standard issue not only among infantry, but also among tank crews, artillery units, and communications teams across the Ukrainian military. However, the challenge of covering an extensive front line that stretches approximately 800 kilometers by September 2025 is formidable and requires a multifaceted approach. EW systems like the Boisville AD, which can jam enemy drone signals up to 12.5 kilometers, provide significant coverage but are large and stationary, suitable mainly for static defense points and fixed installations. Portable EW units, which are crucial for mobile and forward-deployed troops operating in dynamic combat zones, have a much more limited effective range of only 1 to 3 kilometers, necessitating their dense deployment in order to cover the entire front line effectively and counter fast-moving threats. Military analysts have estimated that Ukraine would need roughly 600 such EW systems to maintain a consistent anti-drone shield across the entire front. The procurement, deployment, maintenance, and training for these sophisticated systems come with a hefty price tag. While initial acquisition costs might be around $1.2 million, the total lifecycle costs, including upkeep, repairs, and comprehensive operator training, could easily push this figure up to $2 billion or more. In contrast, shotguns, which began to be locally produced starting in May 2025, offer a more affordable and kinetic alternative for close-range drone defense. These weapons provide a last resort option capable of physically destroying drones at lower cost, though their effectiveness is limited by range, environmental conditions, and the skill of the operator. Equipping all frontline forces with shotguns would require tens of thousands of units, costing tens or even hundreds of millions of dollars. Although this is less expensive than deploying hundreds of EW systems, the logistical burden of distribution, training, and ammunition supply remains significant and challenging in a high-tempo combat environment. Despite these combined efforts, Ukrainian forces still face ongoing challenges in fully neutralizing the drone threat. Consequently, in 2024, Ukraine has intensified research and development efforts to create new, innovative solutions aimed at enhancing anti-drone defenses, including advanced detection technologies, improved EW capabilities, and integration of artificial intelligence to automate counter-drone responses, all intended to maintain battlefield advantage and protect critical assets against increasingly sophisticated drone incursions and evolving enemy tactics. Ukraine employed inexpensive, widely available FPV first-person view quadcopters as a strategic countermeasure to Russian reconnaissance drones, such as the Orlan 10, which are produced in vast quantities, numbering in the millions annually. These affordable drones, typically costing only a few $100s each, offered Ukraine a cost-effective and scalable alternative to Russia's more expensive UAVs that are equipped with sophisticated sensors, cameras, and advanced communication systems. Ukrainian pilots demonstrated extraordinary skill and ingenuity by intercepting and destroying Russian UAVs through daring midair collisions using specially modified FPV drones designed to ram enemy targets effectively. This innovative tactic significantly disrupted enemy surveillance and intelligence gathering operations, although it demanded exceptional piloting skills, precise maneuvering, and was physically and mentally taxing for the operators involved. To enhance the efficiency and destructive capability of these interceptors, Ukrainian engineers began equipping the FPV drones with explosives, effectively transforming them into flying bombs that could destroy enemy drones on impact. While this method increased the lethality of each interception, it also meant the complete loss of the interceptor drone with every engagement, thus limiting the sustainability and operational endurance of this approach. To overcome this limitation, Ukraine advanced the development of FPV drones fitted with shotguns capable of firing on enemy UAVs and then returning safely to base, allowing pilots to conduct multiple sorties without losing valuable hardware. Initially, these shotgun-equipped drones faced significant challenges, including limited ammunition capacity and recoil forces that destabilized flight and impaired targeting accuracy. However, Ukrainian engineer Andrei Pavlovsky innovated a recoil-free shotgun shell, which substantially improved flight stability and shooting precision, enabling more reliable and repeatable engagements against hostile UAVs. In addition to these offensive measures, Pavlovsky also designed the Aerotrol, a compact and cost-effective device that captures enemy drones in a net rather than destroying them outright. Priced at approximately $18.50 each, the Aerotrol became widely adopted by Ukrainian forces as it allowed troops to recover intact Russian drone hardware for detailed analysis and intelligence gathering. This capability provided Ukrainian electronic warfare specialists with invaluable insights into Russian drone technology, communication protocols, and electronic countermeasures, thereby enhancing their ability to develop counter-drone tactics and electronic warfare responses. The Aerotrol demonstrated its effectiveness against a variety of Russian drones, including those deployed in ambush scenarios and fiber optic cable-guided UAVs, which were previously difficult to neutralize without destruction. By capturing these drones, Ukrainian forces gained critical information on enemy tactics, operational patterns, and technological advancements, significantly improving their counter-drone strategies and contributing to a more robust defense against aerial reconnaissance and attack UAVs. This multifaceted approach, combining low-cost offensive drones, innovative shotgun systems, and intelligent capture devices, exemplifies Ukraine's adaptive and resourceful tactics in modern drone warfare, showcasing how ingenuity and technological innovation can offset numerical and technological disparities on the battlefield. Fishing vessels and warships have long used nets to sweep for mines, and applying netting to trap drones is not a novel concept. Several net-based drone interception systems are already operational, with some having been deployed in Ukraine. Among the most recognized is the Drone Hunter F700 from Fordham Technologies, an autonomous VTOL drone that employs a unique net-based mechanism called net guns to rapidly launch expanding nets at hostile drones. This system comes in two variants: a smaller net designed for attack mode targeting Group 1 and 2 FPV-type drones, and a larger net for defense mode used to intercept bigger, faster fixed-wing drones like the Geron. Captured drones are tethered and safely landed for forensic investigation. Another notable system is the Defend Air system from Aero Technologies, which offers multiple configurations, including an interception drone, a stationary turret, or a handheld net gun. It captures drones midair with nets ranging from approximately 30 to 330 feet, operating at distances between 6.5 and over 300 feet. This system integrates with radar, command and control, and RF systems designed to minimize collateral damage in urban or sensitive environments. Other systems address specific scenarios. For example, Skywall Patrol from OpenWorks Engineering is a handheld device that fires a net attached to a parachute, ensuring a controlled descent and minimizing damage to the captured drone for intelligence purposes. Similarly, Iron Drone is an AI-enabled automated drone that uses ballistic nets and parachutes to capture and safely lower hostile drones. Russia has also experimented with net-based anti-drone systems, such as its Net Comet, which features small interceptor drones that launch nets to entangle Ukrainian drones midair. Both Russian and Ukrainian forces have extensively deployed anti-drone fishing nets above critical logistic routes to prevent enemy drones from attacking convoys. Amidst this competitive landscape, Aerotrol distinguishes itself with several key advantages despite the presence of well-funded, more established systems. Notably, Aerotrol is entirely mechanical, without onboard electronics, and mounts onto a quadcopter frame measuring 10 to 15 inches. Unlike other systems, including Russia's, which rely on electronic components that increase cost and assembly complexity, Aerotrol employs vertical slings, thin, high-strength cords designed specifically to snare drone propellers rather than capture the entire drone. This design results in a system weighing just over 10.5 ounces, significantly lighter than typical shotgun interceptors that weigh approximately 5 times as much. The lightweight nature of Aerotrol minimizes impact on the carrier drone's flight performance, unlike heavier systems with electronic parts that burden UAVs. Furthermore, the sling structure does not affect aerodynamics, and its thinness renders it nearly invisible to enemy operators, especially at a distance, or when utilizing a Kevlar variant tested by Pavlovsky. The simplicity of Aerotrol is another advantage. It can be attached to a drone in about a minute using ties or clips and is ready for deployment immediately upon takeoff, streamlining its operational use. In an exclusive interview with Ukrainska Pravda, Pavlovsky provided a detailed explanation of how the Aerotrol system operates, beginning with the initial detection of an enemy reconnaissance drone. This detection can occur either through radar systems or via visual confirmation by operators, ensuring multiple layers of surveillance to reduce the chance of missing incoming threats. Once the hostile drone is identified, the Aerotrol carrier UAV is deployed swiftly to intercept the target. Ideally, this UAV is equipped with a thermal imaging camera, which enables precise tracking even in low visibility conditions, such as night operations or adverse weather. This enhanced tracking capability is crucial for maintaining a lock on fast-moving or evasive drones. The system is designed to engage the target multiple times if necessary, allowing for several capture attempts to maximize the chances of a successful interception. When the Aerotrol snags the enemy drone with its net, the Russian pilot remains completely unaware of the threat until it is too late, because the Aerotrol UAV is effectively invisible from a distance, and the reaction time is insufficient once the camera locks on. This stealth element gives Ukrainian forces a significant tactical advantage. Unlike other net-based drone interception systems, Aerotrol's primary design focus is on defensive operations over frontline Ukrainian positions, particularly emphasizing the protection of assault and infantry units, including special operations forces who are often deployed in high-risk, close-quarters environments. In contrast, many existing systems are engineered for broader defensive roles, such as protecting critical infrastructure or urban areas from long-range drone threats. Aerotrol offers two distinct engagement modes to provide versatility depending on mission requirements. One mode allows the system to detach the captured drone, causing it to fall immediately and neutralizing the threat on the spot, while the other mode enables the Aerotrol UAV to bring the captured drone back to friendly forces for intelligence gathering once the captured drone's battery is depleted. This dual-mode capability enhances both tactical flexibility and strategic intelligence collection. One of Aerotrol's standout advantages is its remarkably low cost. Each unit costs just $18.50, making it vastly more affordable than alternatives like the $20,000 Skywall 100 or the $325 Varta Drone Hunter. This low price point translates into an excellent cost-to-kill ratio, especially when compared against Russian drones that typically cost between $1,000 and $5,000 each, allowing Ukrainian forces to efficiently defend against multiple incursions without exhausting financial resources. A Ukrainian unit equipped with Aerotrol successfully shot down 14 Russian UAVs over the course of just 15 sorties, demonstrating the system's operational effectiveness in real combat conditions. Development of the Aerotrol continues actively, with recent adaptations including the integration of small explosive charges designed to target and disable larger or more heavily armored enemy assets, as well as Kevlar slings that are almost invisible until close range, further enhancing stealth and capture reliability. The system's design drew inspiration partly from the Russian Net-Comet drone capture technology, but was significantly improved to be more effective, reliable, and affordable, addressing the specific needs of frontline Ukrainian troops. This combination of affordability, versatility, and tactical innovation positions Aerotrol as a key asset in Ukraine's ongoing efforts to counter hostile drone incursions efficiently and cost-effectively. The Russian drone's rectangular shape acts like a sail, which diminishes its maneuverability at high speeds and makes it difficult to control effectively. Additionally, the net designed to capture drones can be pushed backward or diverted off course by strong winds, meaning that operating it successfully requires highly skilled pilots and favorable weather conditions. Even when these conditions are met, the vertical net configuration prevents the captured drone from being transported back or used to deliver explosives in subsequent attacks. Pavlovsky drew inspiration from the Ukrainian Dronarium Drone Academy team, which had demonstrated a similar design in Japan in 2015 and faced comparable challenges. This team also contributed to the development of Aerotrol. By adopting a completely new approach, Pavlovsky was able to overcome the limitations of that earlier design. He recalled conducting tests with experts from the Dronarium Training Academy who showed strong interest and led to the proposal of incorporating the Aerotrol drone capture system into their training curriculum. With numerous advantages for the Ukrainian military and promising initial progress, the next goal for Aerotrol is to enter serial production. However, Pavlovsky will need additional help, as a single individual without technical training can produce up to 10 Aerotrol units daily, but he has been manufacturing all of them alone until now. Plans are actively underway to scale up production, and it's possible that Aerotrol could soon become one of Ukraine's, and potentially its allies', most widely used and recognized weapons. We will continue to provide updates on the latest developments in drone warfare, so be sure to subscribe to the channel and enable notifications to stay informed.